Hi everyone and welcome to another lecture. Today we want to talk about determinant of a matrix. So let's get started. So first we need to talk about what is a determinant. A determinant is a scalar, that is a number, and it contains some encoded information under linear transformations of that matrix. What I mean is that let's say you have a matrix called S and you do some linear transformations of it. So this determinant captures some invariance of some features of S under linear transformations. This will be more clear when we talk about an example. Next thing we want to ask is, when is a determinant defined? This is the second question we are asking. So can we do determinant for any matrices? That is, can we compute determinant for any kind of matrix? Let's say you have a matrix like this, 1 2 3 4 5 6. Can you compute a determinant from this? The answer is no. Determinant is only defined for square matrices. So if I had a matrix like A, that is 1 0 2 5, for this kind of matrices there is a determinant. Determinant of A exists. So can you do a determinant for this? Let's say B, take it to be a column matrix 1 2 3. For this, determinant of A does not exist. Now let's try to see how we can compute the determinant of a matrix. Let's take a 2 cross 2 example, that is our square matrix of 2 times 2. Let's take it 1 2 4 7. So the idea is to start from anywhere. That is, you can either start from this row, let me choose another color, this row, and if I do that, the first thing I need to do, I need to take this number over here, that is the 1 1 element, that is just 1. So you write that, and then you have to look what is the element across it, that is this direction, diagonally. This is 7, right? And you multiply them. Then you put a minus sign. The reason for minus sign will be explained in a few seconds. You have 2, right? And then you look across diagonally and you see 4. So you type 2 times 4. If you evaluate it, this is just minus 1. So what did we do here? Let's clarify in details. So let me write this matrix again so that you can see what I actually did. So I started working with this row, and when you start working with this row and you take this element 1, then you have to forget about this row and this column, both of them. You forget them, and the only thing that remains is 7. Similarly, when you work with 2, that is the 1 2 element, you forget about first row and the second column, that is this row and this column. So in general, if you had a n cross n matrices, matrix, and let's say you have it like this, a1 1 a1 2 da 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 a1 n, and there are more over here. If you start from here, you take this element first and you forget about the corresponding row and corresponding column. That is, when you take 1 1, you forget row 1 and column 1 exists. So this is the first step, and then you do the rest. Returning to our 2x2 example, because we will deal with some more examples, and then you can go on and compute n cross n. In general, this is a very long computation if you want to do it by hand. So again, let me write my matrix again. A 1 2 4 7. So the first step is to forget about the rows and columns. But you might ask, where is this minus sign coming from? That is this one. So there is a general rule called the -1. Sorry. The general rule is like this. You have a -1 R plus C. So this row that is